Okay, let's continue with geometrical isomerism in coordination number 4. The last example that we did was MAB2. Similar to MAB2, we can have MABB2, or we can have MABBC. Barobar? How will that look like, people? So center में you have M. So AB, and this is B2. So this is which configuration? Cis or trans? And AB this is trans, yes or no? Yes is it? And this is trans. What makes you say this is cis? Both are same structures. Will it show any GI? Nope. MABB2 is no GI. Did you will get that? Bolo re. But what about MABBC? I can have like AB and AB. Then there's B here and C over here. How will I change the structure? So what it's like what's the angle between A and B? What's the angle over there? 90. So I can have B here and C over here. Yes or no? Did you people get that? MAB and BC. Next. This actually completes geometrical isomerism in coordination number 4, that is square planar complexes. But मेरे को एक और example पढ़ाना था. We usually don't go that deep, in that kind of compounds. But if I give you, let's say MA4, no GI. Will it show any GI? No. But specifically, if I give you MCN4, will it show GI? Because it's same to MA4. MA4 ही है ना वो. So will it show GI? How? Because CN is a ambidont. तो यहाँ पे देखो, see this is CN, correct? I can have NC. Did you get that? And the second configuration, so let's say if I say this is cis, because the angle here between C and CN is 90. What can I make over here, people? I can put a CN over here, and यहाँ पे CN डाल देना. What's the angle between C and CN? 180, and then NC and NC. Did you get that? So this will be cis and this is trans. So even MA4 can show GI provided it is an ambidont. But then every non GI ones that we have written उसमें ये हम exception लगा के जा सकते तो बाबा तो और infinite combinations आ जाएंगे. For example, if I say MA3B and if I make that A also CN and saying that it is ambidant, तो वो भी GI दिखाने लगेंगे. But we are not going that. So सिर्फ we are not doing that. सिर्फ एक example ऐसे लिख के रखना कि even though it is MA4, it can show GI something like this because of its ambidentate nature. Did you people get that? Bolo, yes or no? So this was coordination number 4, square planar complexes में GI. Let's go through this once again. Tell me the first compound that we wrote. MA2B2. देख के आप बोल सकते हो. What was the second one that we wrote? MA2BC. Then after that we wrote MABCD. Notes. Then what did we write after that? फिर हमने नॉन जीआई वाले लिखे थे लाइक MA4, MA3B, देन MAB3. 3 कैसा हो सकता है? कोऑर्डिनेशन नंबर तो 6 हो जाएगा. MAB2, देन वी रोट आई थिंक MAB2, आगे नो जीआई. देन आई थिंक ये लास्ट 3 लिखा था. ठीक है. So this is the list of coordination number 4 geometrical isomers. Any questions here, anyone? Chalo. Now we move on to coordination number 6. इस पे डायरेक्ट हम stereoisomerism पढ़ेंगे. Cases where we have GI, cases where we also have optical isomerism. ठीक है. Chalo, let's start with the first one over here. So this is stereoisomerism in coordination number 6. Coordination number 6 मतलब what people? Which complexes? Octahedral complexes. Let's start with the first octahedral complex, which is MA4B2. ठीक है. We apply the same rule. Cis and trans का the angle between the cis and trans isomers, cis and trans ligand जो हम consider करेंगे will be how much? 90 degree. And trans के लिए it will be, cis will be 90 and trans will be how much? 180. But एक और छोटा सा change करेंगे. Now people over here select the ligand which is repeating twice. So कौन सा ligand आता है हमारे पास? वो B वाला. Just give me a moment. The next coordinate bond will be above the plane and the last one is below the plane. Sure. So select the ligand which is repeating twice. So I'll pick B over here. So B, I want cis. So the angle between B should be 90. I can place, or before that, can someone tell me if I consider, okay, let's say this is like position number 1, 2, 3, 4, 5, 6. Which all different positions can be considered as cis? What's the angle between 1 and 2? So like 1, this is 90. What is the angle between 1 and 3? Angle between 1 and 4. Angle between 1 and 5. 90. What is the angle between 2 and 3? 2m3. 3m4. 4m5. 5m2. All those are 90. Are there more 90 degrees? कहाँ पे? 6, 3, 6, 2. So 6, 3, 6, 2, 6, 5 and 6. All these have 90-degree angles in between them. So I can classify all of them to be as cis configuration. What about trans? 1, 6, 2, 4, 5, 3. All these will be classified as trans configuration. Everyone got that? Bolo re? Yes or no? So over here, I want to put B in cis configuration. Where will I place them? I can place 1, 2, 1, 3, 1, 4, 1, 5. कहीं पे भी, right? But simple रखने के लिए I'll place it here. BB cis. And I can place trans के लिए 1 ऊपर and 1 नीचे. So this will be cis. घर पे revise करने के लिए you can take that we took BB as reference over here. Trans, the angle is, so rest all positions we are going to write what? So MA4B2 shows two geometrical isomer, one is cis, the other is trans. Also MA4B2 is optically inactive. Why is it optically inactive? Because there's a POS, plane of symmetry available. Can someone tell me in this structure where can I have a plane of symmetry? इसको अगर ऐसे बीच से कट करूं तो I can simply fold A on A and B on B. Anyone who did not get that, वापस से plane of symmetry बताता हूँ. Where is this A? Assume this to be the square planar structure, the board. A and A is here. A, B, B. Where is this A? Center of the board coming out towards you people. Where is this B? A? Going away from you. Now cut it center se, like this. That will also cut these A's. And now you can fold the board. A will overlap with A and B will overlap with POS. There is presence of plane of symmetry and hence it is optically inactive. Did you will get that? Bolo re. Now MA4B2 बना है. What will the next be? ना B2 को you can further split as MA4BC. कैसा स्ट्रक्चर रहेगा फिर MA4BC का? MA4BC. Come on, quickly. Which two ligands will you select यहाँ पे काम आसान रखने के लिए? BC cis, BC trans, A. So this is cis with reference to BC, and this is trans with reference to BC. Again, optically inactive. Why optically inactive? Because of the presence of plane of symmetry. Any questions यहाँ पे anyone? बोलो रे. चलो. Now we started with MA4B2, MA4BC. What will the next one be? M. Excellent. MA3B3. Then the B3 is going to become B2C. Then the B2C is going to become BCD. अब हो गया A3, B3 and B3 combinations. What will be after that? MA2, B2, C2. Then next A2, B2, CD. Then A2, B, C, D, E. And the last one will be M, A, B, C, D, E. A, B, C, D, E, F. ऐसे सबका स्ट्रक्चर बनाना है. ओके, चलो जल्दी जल्दी, टाइम नहीं अभी. दिस इज M, A3, B3. MA3, B3 is slightly different. Okay. Now, first A is present here. Position coming out towards you. एक A को यहाँ पे place किया. And the next A is here. Join them. एक हाइपोथेटिकल लाइन से ज्वाइन करो, एक इमेजिनरी लाइन से ज्वाइन करो ए को, तो क्या मिलेगा? What do you get here? You see a triangle. I don't know, दिख रहा है कि नहीं दिख रहा है? Yes or no? Similarly, B and B, join them opposite. You'll get a triangle. The face of a triangle. This isomer is called as facial, face of a triangle, or FAC. Getting that? Basically, they are all cis positions to each other. Yes or no? अब एक cis को change कर दो into trans. So A was here, A, but the next A is here. Join them. What do you get? Again, what do you see here is a, where will you place B? There's one B here. And B here. Join them. Again, what do you see? Can you see like two triangles cutting each other? This is called as मेरिडोनल. शॉर्ट फॉर्म में MER. Both are optically, everyone optically inactive due to the presence of plane of symmetry. Chalo, next, after M, A3, B3, give the next one. M, A2, BC. अब यहाँ से मुझे चाहिए, आप लोग स्ट्रक्चर ट्राई करो. I'll help you. M, A3, B2, C. Please technique देखो. You have A3, B2. So I place A and A. ठीक है? Face of a triangle. B and then C. Next, अब क्या करूँ? Move एक B के पोजीशन को with one C पोजीशन. तो क्या हो जाएगा people? A and A. So let's say move this B with this C. So that B is over and the C is over here. किसे भी मूव करते, इससे मूव करते तो भी it would have been okay. ये BC makes no difference. Getting that? बोलो रे. Next किसके साथ मूव करेंगे? There's one more. ऊपर कौन था? A and C. Next कौन आया? A and next ऊपर कौन हो सकता है? Yes, B and C. So let's see, ये A और एक B को swap कर दिया था, तो you have A, B, C and one more B. अप एंड डाउन के लिए कर सकता है. Now, चलो, now M, A3, BCD. Again A3 को facial position A and then BCD कहीं पे भी डाल दो. Let's say B, C and B. ठीक है. Next क्या करेंगे people? Let's swap C with, or let's start here, D with A. So D was here, now D is here and A आ गया यहाँ पे. Rest of the structure will remain the same. You will C here, B over here, A and A. Next, we'll swap C with A. So C over here and A over here. क्या मिल जाएगा? This is B, this is D, A and A. Position swap नहीं किया मैंने. and the last one, so AB हो गया, BD, BC, and what is left? Transposition पे AD, and AD बचा था, yes. So एक A यहाँ पे, एक दो, A यहाँ पे, and then B and C. Total number of isomers that we have here is 4, and over here the cis isomer is optically active and trans isomers are optically inactive. Total number of actually isomers then should be cis and trans. Cis will give you DNL, so total number of isomers are 5. ठीक है? So next I'll give you a पूरा table with all the different configurations. कौन से configuration थे people? We started with M, A3, B3. What was the second one? Sorry, pardon me. We started with सबसे पहला M, A4, B2. But इसके पहले we could have had M, A5B, or we could have had उसके पहले M, A6. But for both, the number of GIs are 0. So geometrical isomer, optical isomer. Geometrical plus optical will give us after M, A4, B2, we did M, A4, BC. Then after that we did M, A3, B3. After that we have M, A3, B2, C. Then we have M, A3, B, C, D. एक और कर सकते थे, but M, A2, B2, C2. M, A2, B2, CD. M, A2, B, C, D, E. And last one M, A, B, C, D, E, F. Now if you look at M, A, B, C, D, F, which are the different combinations that you can make? It's just about finding different combination, people. AB can be one combination. So AB can be with respect to each other cis, with respect to each other trans. Then A, C, A, D, A, E, A, F. So how many such combinations are possible just with A, AB, AC, AD, AE and AF? कितने combinations है people यहाँ पे? 5. Then with B, how many different possible combinations with B? Can I write BA? No, because it's already covered here. So it will be BC, BD, BE, BF. So how many such combinations are possible? 4. Then with C, CD, CE, CF. Can I have CB or CA? No, because they are covered here. How many combinations? 3. Then इसके बाद DE, DF. How many combinations? And last EF. Total number of isomers? 15. 15 geometrical, and all the 15 are also optically active because none of them will have a plane of symmetry. So just say if I want to make it for M, A, B, C, D, E, F, how many GIs will I have? 15. And how many optical isomers? 15. Remember 15 D and L. So total number of stereoisomers 30. You can either remember it like this या एक टेबल देता हूँ, आप उस टेबल को मेमोराइज कर लो. चलो, last few structures are left. So these were all monodentate. We now move on to bidentate. Let's take the first bidentate M. AA3. What does AA here represent? It's a symmetrical bidentate. ठीक है? So example लेके भी करते हैं, normal structure भी बनाते हैं. Let's say we take the example as MEN thrice. EN stands for ethylene diamine So this is A, एक position, there's A over here. With reference to this board, tell me where are they? Where is this A coming out? Where is this A? That corner join कर दो. What about this A and ये वाला A? Correct. And this A and this A, they're on the same plane. I guess A and this is joined here. Samjha? Now MA thrice or MEN thrice can show only optical isomerism. There is no geometrical isomerism. I repeat, it can show only OI but no GI, which means that if there is a D form, there will also be uska ek L form. L form matlab if one is dextrorotatory, the other one will be levorotatory. Mirror image. So this A will still remain here. Where is this A now? Similarly, ye A and A will move over here. And the last one, if this is, let's say, the D form of the compound, then इसको हम क्या बोलेंगे people? L form. Did you will get that? Now, let's take an example to understand this. What is the bidentate that we have taken here? Ethylene diamine. एक easy way में you can simply write EN and you can simply show it like this. Getting that? And you can make its optical isomer. Okay. Or you can show pura ethylene diamine. What that means is, what are the donor atoms? NH2, CH2, CH2, NH2. Getting that? Then NH2, CH2, CH2, and then you have one NH2. Or you can show or the third one is over here, NH2, CH2, CH2, and then you can make it like this, or you can make it like this, because this is for boths basically. दोनों में से कोई भी स्ट्रक्चर बनाओ, both are correct. I've just made the D form, उसका mirror image. I want you people to do it. Now, we started with M, AA3. What can the next combination be? M. If you have a symmetrical bidentate, you can also have a unsymmetrical bidentate. What will the unsymmetrical bidentate will look like? M, AB3. So instead of wherever we have AA, you can change A to B और same ही structure मिलने वाला है. For MAB3, जैसे कि एक A, change that to B. Did you people get that? Yes, yes, yes. Optically active, and also only no geometrical isomer, only optical isomer. This will be M, AB3. So, give me the next combination, please. I want to reach coordination number 6. So, I can next have M, AA, AA to B2. Then I can go ahead with M, AA to BC. The same with AA, I can write the same with M, AB to B2, or I can write the same M, AB to BC. However, the number of isomers will change. Again, इसके लिए भी I'll give you a table with some specific important ones. Can
you have AB and AA in the same?
Yes, yes, yes. You can also have M instead of A to या AB to M, AA, AB, B2. Combinations such as this M, AA, AB, and then B2. Or you can have M, AA, AB, BC, so on and so forth. तो ये सब के लिए I'll give you a table. But एक example ले लेते हैं. For example, M, AA to B2. So B2 cis and B2 trans. Then I have AA, so you can have A here and A here, then A here and A over here. What about this? A, join them. This is cis configuration, this is trans, and the cis configuration is optically active. There's no POS, and the trans configuration is optically inactive. When instead of B2, if I put BC, all you have to do is instead of 1B, आप क्या डाल दो वहाँ पे C. Did you will get that? बोलो रे. So just like ये एक table बनाया था, I'll also give you a table for all the bidendates. समझा? जल्दी जल्दी copy this. Okay, we will be stopped for the day. I'll share the table for bidentate B. Next class we start with nomenclature of coordination compounds. Nomenclature करना है, organometallic compounds, synergic bonding करना है. And then there's one small topic which वो मैं group पे डालूंगा, which is uses of coordination compounds. So hopefully probably next lecture में हो जाना चाहिए.